So I have another new vocabulary word for you, complex fraction. A complex fraction is a fraction with two or more terms in the numerator or denominator of a fraction. So basically, there's either an addition or a subtraction that's in the top or the bottom of the fraction. Let's check to make sure you understand this. I've given you 4 expressions, and each one I want you to circle the ones that are complex. In the first expression we have x over 2. I don't see any operation on the top or the bottom, no plus or minuses, so we just have one term over one term. So that is not a complex fraction. In the second expression, x minus 2 over 3. Do you see how you have an operation in our numerator? So that means there's two terms in the numerator of this fraction. That makes this big old fraction a complex fraction. In the third expression, you have 3 over x plus 2. Look in the denominator. Do you see how you have an addition sign in the denominator? That means that there is two terms in this denominator. That makes this fraction complex. In the final expression, you have 3 plus 2 over x. I do see that operation of plus, but it's not in the numerator or the denominator of the fraction that I see in the problem. So this is not a complex fraction. So what's so important about complex fraction? Complex fractions must be undone with multiplication before you combine your like terms or isolate a variable from its coefficient in an equation. So look how the way I wrote the word complex with the capital X to help you remember that complex you multiply. So look at problem number 3. It says, what is the solution of 6 is equal to x minus 2 over 4? Do you recognize that complex fraction? The equation has two operations, subtraction, right here, and division. See, it's all being divided by 4. To isolate the variable x, we have to use addition so that we can get rid of the 2 and multiplication. But we have to undo the complex fraction first. So we're actually going to undo this division by multiplying, moving it up and multiplying. And normally when I say complex fraction, remember that x, I will generally draw an x with an arrow pointing to each side. Now the 6 is not a complex fraction or a fraction, so I'm not really multiplying anything to this other side of the x plus 2, but I do need to multiply the 4. So I'm going to move it up and multiply the 4 to both sides of the equation. Once you do that, you need to simplify it. The 4 will cancel out the 4, so we have 6 times 4 equals 24 equals x minus 2, because the 4's cancel out. The next step, we need to combine our like terms. We have that positive or negative 2, which is a constant, that we need to combine with the 24. So let me just copy down what the problem originally looks like. Then we would need to add 2 to both sides of the equation. And then simplify. Well, the minus 2 plus 2 is a 0 pair, so that cancels out. 2 plus 24 is 26. Now, I don't generally write my problems all horizontally like this. It just so happened to do in that example. Okay, let's apply this. Cross multiply your complex fractions. So I'm going to cross multiply my complex fraction. So the 2 that I see here, I need to cross multiply to the other side and this nothing, so the b plus 2 remains equals, and I'm going to multiply my 2, sorry, clean this up here. I'm going to multiply my 2 to the other side of the equation by multiplying by 2, multiplying by 2 to both sides of the equation. Yeah, that was a negative 5 there. So I need to simplify. The 2's cancel out. That's how I get the b plus 2. Negative 5 times 2 is negative 10. So I've cross-multiplied. After I cross-multiply, then I identify my terms, kind of put on those training wheels so that I know what to do next. I have a variable term, a constant, and a constant. Now I can clearly see that I need to combine my like terms. I need to subtract 2 from both sides of the equation, draw my big fat line, and combine. The 2's become a 0 pair, so on this side of the equation I just have b is equal to, and then I have a negative 10 and a negative 2. I use my rule, my SOB, to combine my like terms. Negative 10 and negative 2, those are both the same sign, so you have to add. 10 plus 2 is 12, but the bigger sign wins. 10 is bigger, and it's negative, therefore my answer is negative. In the last step, I need to isolate my variable from its coefficient. It has a coefficient of 1, so actually I'm done. I don't need to do that step this time. So finally, I need to check my answer. And so to check it, now this is going to be a little bit more complex because it's a complex fraction. I have b, but instead of b I'm going to write a set of parentheses, plus 2 all over 2 is equal to negative 5. This is what the original equation said. Then I'm going to plug in the negative 12 that I just got into the parentheses and simplify the expression that's on the left-hand side. I'm going to start by simplifying the numerator there, negative 12 plus 2. And I've run out of room here, so let me see where I can do this for you. Negative 10 over 2 is equal to negative 5. And then negative 10 divided by 2 is negative 5. Negative 5 equals negative 5, so it checks. The answer is b is equal to negative 2, or negative 12. Knowing when and when not to apply cross multiplication with your complex fraction is a little tricky, or it's just you just need to practice it and be able to identify, make sure you understand the definition of complex fraction. So let's take a look at these two equations. One equation says negative 8 plus x over 12 is equal to negative 1. The other one is negative 5 is equal to negative 6 plus x over 8. Which one of these equations has a complex fraction in it? Equation 1. So I must apply cross multiplication. So I'm going to cross multiply the 12 to the negative 1 in order to get rid of that 12. So you times by 12 to both sides. Cancels out the 12, and you simplify. Negative 8 plus x is equal to, well, negative 1 times 12 equals negative 12. Alright, so we've done cross multiply. I'm just going to put a C for cross multiply. My next step is to identify. I'm just going to put an I to remember identify. So I need to identify my terms so that I know what to do next. Negative 8, is that a constant term or a variable term? It's a constant, so I'm going to put a square around it. Positive x is a variable. Negative 12 is a constant. Let's go and look at the other equation. Do the same thing. Let's apply the same step to both equations. Negative 5 is a constant. Negative 6 is a constant. And positive x over 8 is a variable term. Alright, I've identified all my terms. Now I can decide what I need to do next. The next step in solving any equation is to combine my like terms. I'm going to put another C there. So I look in equation 1, do I have any constants that I need to combine? Yeah, the -8 and the -12. Well, before I can combine them, now which am I going to combine? Am I going to combine the 12 with the 8 or the 8 with the 12? Well, he said the -8 with the 12. So I have to make that zero pair of +8 to both sides. I chose the 8 because that's the constant that's on the same side as the variable. My goal is to get that variable all by itself. And variables are stubborn. They like to stay put. Alright, draw your big fat line and combine. So that creates that zero pair, and x is equal to then, well, -12 plus 8. Those are opposite signs, so you have to subtract. Equals 4, and the bigger sign wins, so it should be a -4. Let's apply the same step to equation 2. Do we have any terms that we need to combine? Looks like a -5 and a -6 are like terms, so we need to combine them. Now what am I going to do? Am I going to have to add 5 to both sides or add 6 to both sides? Do you see how the -6 is on the same side as the variable? And our goal is to get the variable all by itself, so we need to add 6 to both sides. Draw your big fat line and combine. On the left-hand side of the equation, you have -5 and a +6. When we combine like terms, we always use SOB. So those are opposite signs, and therefore you have to subtract. 6 minus 5 is 1, and the bigger sign wins. It's positive. Now it's the only term that I have on the side of the equation, so I'm not going to write the plus sign. On the right-hand side of the equation, we combine our like terms. Well, that's a zero pair, so they cancel out, and we're just left with x over 8. Alright, our last step in solving equations is isolating our variable. Do you see the CI? Alright, so equation 1, our variable is already isolated. So equation 1, we're done. That's the answer. In equation 2, our variable is not by itself yet. There's an 8 that's under it. What do we say? If it's under, we have to move it up and multiply, because it's being divided by 8, so therefore the inverse is multiplied by 8. Our 8's cancel out, so we have x is equal to, and we simplify the other side, 8 times 1 is 8, so we have 8 equals x. Or you can turn around and write it in standard form, x is equal to 8. There's our two solutions. And yes, I would always recommend that you go back and check. Look at that, CI. Alright, let's check this real quick just to make sure we did them right. I'm going to have to erase a little bit just so that I have room to check. I think if you've written small, you have room on your paper, or there's some extra space in the margin that you can check your answer. So let me erase a little bit so that I can have room myself. Okay, I think I copied the answers down correctly. If I didn't, then I know that I'll find out here in a minute when I check. Alright, the first equation, I have -8 plus x. But I'm not going to write x. Instead, I'm going to make a set of parentheses. All over 12 is equal to -1. I'm going to substitute in my -4 right in that placeholder of the parentheses. And then I simplify the left-hand side of the expression there. I have -8 plus -4. Those are the same signs, so I have to add, and the bigger sign wins. So you should get a -12 over 12, which is equal to -1. So my solution checks. X is equal to -4 is correct. In equation 2, I have -5 is equal to -6 plus, make a set of parentheses where I see that x, all over 8. And I plug in the 8 inside the parenthesis there. And now I'm going to just simplify that right-hand side of the equation. I have a negative 6 plus 8 over 8. What do I do first? Do I take negative 6 plus 8, or do I do the 8 divided by 8? Remember your order of operations. Please excuse my dear Aunt Sally. 8 divided by 8 is a division problem, so I need to do that first before I take care of that negative 6. So I have negative 6 plus 8 divided by 8 is 1. Negative 6 plus 1, I have a negative and a positive number, so I combine by subtracting. 6 minus 1 is 5, and the bigger sign wins. Well, 6 is bigger, and it's negative, therefore my answer is negative. Does that equal the negative 5 on the right-hand side of the equation? Sure does. So my answer checks. Alright, good luck with your guided practice for 1.9, and ask your instructor if you need any help.